Hi guys, so we're going to start test 5, and this is over functions and graphs. 16.1 is all about identifying functions. So we're going to learn a lot of vocabulary words and how to identify functions. So these are the notes. I've filled in some of the information already just to kind of help move the video along. But remember, this is a video, so you can pause at any point in time to fill in whatever information you need. You can also rewind and listen to me again. Okay, so if we have this equation, y equals 2x minus 3, and we try to determine if this is a function, what we want to do is we want to make an input-output table. So instead of it just being called x, we're going to call it our input, because this is what we're going to put into the equation. The thing is, you get to pick your inputs. I like to pick a negative number, a 0, and a positive number. And -1, 0, and 1 are perfectly acceptable. They kind of give you an idea of what's going on. You can always pick more than 3, but 2 to 3 is a good idea. 3 is generally what is needed. And then we have the process column, which this just means what are we going to do with our input? So kind of think of a function like a Coke machine. You put a quarter in, or not a quarter, a dollar in, and hopefully you get a Coke out. So the process is the vending machine taking your money and giving you the desired drink. So we put in our -1 into our process, 2 times -1 minus 3, and our output should be -5. Same thing with 0 and 2. We put it into the process and we get our output. So our y column is also our output. We also get two other names for our input and our output. The set of the input is called the domain, and the set for the output is called the range. So this table represents a function because each input or members of the domain corresponds with exactly one output or members of the range. So I put -1 in, I know I'm going to get -5 out. I put 0 in, I know I'm going to get -3 out. When you go to a Coke machine, you put your dollar in and you expect to get a Coke out, or whatever your desired drink is. That makes it function. It's a properly functioning Coke machine. So that's kind of how you can kind of think of a function. You put something in, you get something out. Another way we can look at and try to determine if something is a function or not is by using mapping. So this column, 4, 9, and 0, these represent our domain. This column represents our range. So when I put 4 into my process, I can either get a 2 or a -2. That's what this shows. When I put 9 into my process, I get either a -3 or a +3. When I put 0 in, I get a 0 out. So I don't know what the process is, but I do know that my input is 4 and I get 2 choices for outputs. So this mapping represents a relation and not a function, because each member of the domain corresponds with more than one member of the range. So if I put the dollar into my Coke machine, I don't know if I'm going to get a Coke or Diet Coke, even though I pushed the Coke button. That's what this is showing you. So it's not functioning properly. You can kind of think of it. Something happens. It does have an input and an output, but we don't know exactly what's going to happen on the output. So this is a relation. And we'll look at some more of these with the examples later. Another thing we're going to look at in this section is finding the values of function and function notation. So if we have that same equation we started off with, y equals 2/3 x, but we say, nope, let's write it as in function notation because we do know it is a function. Then this little guy here, this little f with the x in parentheses, that's our function notation. And we read it as f of x, or you can say the function of x. Doesn't really change anything, it's just a different notation. So you'll see this, sometimes it's not f, sometimes it's other things, but it just means this is the function of x. Whenever we're trying to find the value, they'll give you a function like this one, function of x of is 3x squared minus 2x plus 8, and then they say find f of 0, f of negative 5, and f of 7a. All that means is that the 0, the negative 5, and the 7a, the stuff in parentheses here, that becomes your input. So they're telling you that's what I want you to use for your input. So we have a little input-output table over here. So let's do this, okay? So we're going to first find f of 0. So 0 is my input. My process would be 3 times 0 squared minus 2 times 0, sorry, my pen is not working properly, plus 8. So we would do our calculation and we would get that our output, or the value of our function, is 8. Then we would do the same thing with negative 5. So we would have 3 times negative 5 squared minus 2 times negative 5 plus 8. So all I'm doing is substituting in negative 5 in place of the x's in my function. And so then I would get that my value of the function would be 93. Oh, that does not look like a 3, but that's a 3. And then the last input is 7a. So this one gets a little trickier, but we still do the same thing. We're still going to do 3 times 7a squared, lost my parentheses, minus 2 times 7a plus 8. And then we'll do some simplifying here, and we would get 147, just have to listen to me on this one because my pen is not cooperating, 147a squared minus 14a plus 8. So all I did was just simplify. 7a squared becomes 49a squared times 3 is the 147a squared. Then you have negative 2 times 7 gives you the negative 14a, and then the plus 8. So these would be the values of my function at those given inputs. And the last part is going to be graphing functions. So what you're going to do is you're going to make your own input-output table. So they say graph the function x plus 2. So you're going to make a little input-output table. I'm just going to make a little miniature one here. And so my inputs, I get to choose. So like I said before, I'm going to choose some easy numbers, 1, 0, and negative 1. And then I'm going to put my inputs in to my function and calculate my outputs. So when I put 1 in, 1 plus 2 is 3. When I put 0 in, 0 plus 2 is 2. When I put negative 1 in, I get 1. So, and the last part would be to plot those points. So, my graph got a little messed up over here, but yours should be fine. So you would plot these as ordered pairs. So, 1, 3, I'm going to kind of make a little mark there. 0, 2, and then negative 1, 1. So those would be my plots, and then I would, when you do it on MyLabs, you have your little line tool. So you would only really need to plot 2 of the points to do it on your MyLabs, but if you're doing it by hand, you would want to do 3. So there would be your line, something like that. So sometimes they ask you to graph the function. Other times they're going to give you a picture, and they're going to ask you, is it a function, just by looking at the picture. You don't get an input-output table. Only thing you get to see is what the graph looks like. So let's sketch a few little graphs down here on the bottom, and then we'll talk about this vertical line test. So we're going to make this one. Whoa, sorry, let me undo that. Okay, let's just go here. There, that's better. So I have my little parabola here. That's supposed to be a circle. And then this one's fun. It's an S. Okay, so the vertical line test says if a vertical line can cross a graph at more than one point, the graph is not a function. So you can kind of think of your y-axis as a vertical line, right? So if I could shift it across the graph, I should be able to draw a line at any point along the graph and only touch in one spot. So if I'm looking at this parabola, if I use my imaginary line here, I can see that it only touches at one point at any place. So yes, this one is a function. Whoops. So we'll give this one a check mark. It is a function. Now, this one, on the other hand, if I draw a line here, you can kind of see it here with the y-axis. I touch here and here. So this one is not a function. And the same thing over here. If you look kind of at your y-axis here, you see that it actually touches in 3 spots. There, there, and there. So again, this one is not a function. That's just by looking at the pictures. Okay, so let's try some examples. Okay, so on this one, the domain is mapped to the range, and for each input we get an output. So if I put t-shirts in, I get $12.99, shorts, blah, blah, blah. So yes, this one is a function. Now this one just gives you words here. So the domain is a set of artists, the songs they've recorded, and the range is a set of songs. Let's just say that our artist that we choose from the domain is Michael Jackson. There's not going to be one song that would come out. He's got a huge collection of songs that he's recorded. So that would not be a function. However, if your set of artists included one-hit wonders, then yeah, you might have a function. But as this is written, no, this one would not be a function. Okay, so these ask you for finding the values. We're going to talk about them a little bit and move on because we have a lot to cover and I only have a few more minutes left on my recorder here. So again, this just means substitute 3 in place of x, so 5 times 3 minus 1. Same thing here, you're going to substitute negative 3 for x, so 3 times negative 3 squared minus negative 3, so be careful there with your signs, that becomes a plus. This one is a minus 2 gets substituted in, so 4 times a minus 2 minus 3, and then you would simplify. Now this one's interesting because it says the function h of x is equal to 5, always. So it doesn't matter what I put in for x, it's always going to be 5, so the value of the function at 8 is still 5. Okay, so this one's going to be graphing, so we're going to graph the function g of x equals 3x minus 1. So again, you're going to make your little input-output table. You get to pick your inputs and calculate your outputs, plot your points, draw your line. Same thing over here. This one's different because it's an x squared, so I would definitely say to pick your negative 0 and negative 1. When you go to graph this one in My Labs, you want to make sure you pick the tool that looks like this because it's a squared equation, so it's going to have a parabola-shaped graph. So just be careful if you get these in your homework to make sure that you choose the parabola shape. And I think you have to pick 3 or 4 points for the parabola shape to graph properly. Okay, so here's the vertical line test again. So again, if I take my graph and I draw a vertical line, sorry that's really crooked, but you get the idea. At any point on my graph, I should only touch at one point. So this one is a function. Again, for my vertical line, if I draw one here, look at that, I hit twice, not a function. Okay, so that's all the vertical line test does. If it touches more than twice, then it's not a function. Basically, if I chose negative 1 as my input, then I can either get something a little bit bigger than 2 or something a little bit bigger than negative 2. So, and the last one is a word problem, an application, so read it carefully, look at your graph, and it's going to ask you to estimate certain things, so it's not that difficult there. Good luck!